Why won't your car start? You have probably already thought about it. Maybe the battery is dead. Maybe the starter gave out. Maybe something is wrong with the fuel pump, and you are about to spend money finding out which one it is. But here is what nobody tells you. The part that actually causes most no-start problems is none of those things. It is something that hides in plain sight, something that almost never triggers a warning light, and something that most drivers, and even some mechanics, completely overlook. Last week, someone paid $800 chasing this exact problem. New starter, new battery, new fuel pump. Car still would not start. The actual fix took 5 minutes. It cost less than a cup of coffee, and it was something that had been hiding in plain sight the whole time. I have seen this happen over and over. People spend hundreds of dollars replacing components that were working perfectly fine. And the whole time, the real problem was sitting right there, invisible, waiting to be found. In this video, I am going to walk you through 16 different failure points that cause no-start conditions. I have organized them from least common to most common. Every section will save you from wasting money on parts you do not need, and what we cover at the end is what experienced mechanics have learned to check first. Number 16, blown fuses and failed relays. Most people jump straight to the battery, the starter motor, or the fuel pump when their car will not start. But here is what almost nobody realizes. A component no bigger than your thumb can completely disable the starting system while everything else looks perfectly normal. What is really happening? Fuses and relays act as gatekeepers of your vehicle's electrical system. They send power to starter circuits and all the vital subsystems. When one of these gatekeepers fails, everything downstream stops working instantly. The result is confusing. You have full battery voltage, your accessories work, your lights come on, but the starter gets nothing because power never reaches it. Here is a fast diagnostic trick. Swap the suspect relay with a known good relay from another circuit in the same fuse box. If the car suddenly starts, you found your problem in 30 seconds without spending a dime. In Chevrolet and GMC trucks, particularly the 2014 to 2018 Silverado and Sierra, the battery junction box has become a notorious failure point. Owners report that aftermarket batteries with non-standard dimensions let the junction box sit loose. It shifts around under vibration and breaks high current contacts on and off, causing complete power loss that comes and goes without any pattern. Some no-start cases trace back to physical damage within fuse boxes or harnesses caused by amateur wiring modifications or shorts that smoked fuses or melted traces. Visual inspection of fuse box internals and continuity checks from relay sockets to solenoids catch these hidden problems. In manual transmission Fords, the clutch safety switch has to complete the circuit before the starter relay can ground. When this switch circuit fails or the relay block contacts corrode, the starter will not engage, even though the battery and starter are perfectly fine. The fix? Clean the junction box contacts and secure it tightly. But here is what most people do not realize. Even if your fuses and relays are perfect, there is another component that fails even more often. Number 15, weak batteries and corroded connections. Across repair shops everywhere, the battery stands out as the single most common cause of no-start problems. It creates more roadside assistance calls than any other single component. But here is what most people get wrong. They check the battery voltage with a meter, see 12 volts, and assume the battery is fine. That is not how batteries actually work. What is really happening? A battery can show 12 volts at rest, but collapse completely when you try to spin the starter motor. This is called load failure. The battery looks healthy when nothing is pulling power from it. The moment you ask it to deliver 200 amps to spin the starter, it dies. Corrosion makes this worse. It forms inside terminals and under insulation where you cannot see it. A battery cable that looks perfectly fine on the outside may have high internal resistance that only shows up under load. Power that should flow to the starter gets wasted as heat in corroded connections. Here is the key diagnostic. Do a voltage drop test while someone cranks the engine. Measure voltage at the battery, then at the starter terminal. If there is a big drop between those 2 points, you have hidden resistance somewhere in the cable or connection path that static checks will never reveal. Before you spend money on a new battery, do a battery load test, not just a voltage check. Clean and tighten your battery clamps. A trickle charger or battery maintainer can safely recover deeply discharged batteries that might otherwise get thrown away. But wait, even if your battery and connections are perfect, something else can prevent your engine from firing. And this is something that almost nobody checks first. Number 14, Dead ignition and spark failure. Your engine needs 3 things to start: air, fuel, and spark. You can have 2 out of 3 working perfectly, and the engine will still sit there cranking forever without catching. The result? Frustration, wasted fuel, and a flooded engine that makes everything worse. So how do you know which one is missing? Here is a quick test that takes 10 seconds. Spray starting fluid into the intake. If the engine fires briefly then dies, you have spark but no fuel. If nothing happens at all, spark is the problem. What is really happening? The ignition system has to deliver a precisely timed, high-energy spark to each cylinder at exactly the right moment. Any weakness in this chain prevents combustion even when fuel is present. Check your spark plugs. Black and sooty plugs mean a rich fuel mixture. Oil-fouled plugs point to engine wear. Wet plugs with raw fuel smell mean the ignition is not firing. Cracked coil towers, damaged plug wires, or poorly seated plug boots let high voltage leak and arc to ground. This kills spark energy and damages other components over time. Here's a tip. In a dark garage, you can sometimes see arcing that would be invisible in daylight. For vehicles with traditional distributor ignition systems, the distributor cap and rotor become extra failure points. Moisture inside distributor caps, carbon tracking from repeated arcing, and worn rotor contacts all cause ignition failures that come and go randomly. But there is one ignition failure that hides better than all others. Almost no mechanic will suspect it unless they have years of experience. Number 13. Failed ignition modules that die when hot. These failures are some of the most maddening you will ever deal with. Here is why. A component smaller than a deck of cards can shut down your entire engine, but only when hot. Then it works perfectly fine when cool. What is really happening? The ignition module depends on heat sinks and mounting surfaces to stay cool. When thermal paste breaks down or mounting points corrode, the semiconductors inside start to drift and fail. The classic symptom is a vehicle that works perfectly when cold, but stalls when hot. It refuses to restart until it cools down. Then it starts perfectly fine. An hour later, it dies again. These failures are maddening because the car may pass every diagnostic test when cool. By the time you get it to a shop, it has cooled off enough to work again. The mechanic finds nothing wrong. You drive home. It dies again. Before you condemn the module, check for cracked coil towers, damaged plug boots, and loose connector contacts. These cause the same symptoms. Advanced tests of ignition control module using oscilloscope waveform capture give solid proof when simpler checks do not. But diesel owners, I need to talk to you specifically. Number 12, diesel injection pressure failure. Diesel engines work completely differently. Everything I just said about ignition and spark does not apply to you at all. Diesel engines do not use spark plugs. They ignite fuel through compression alone. What is really happening? Just because you hear the fuel lift pump running does not mean you have the extremely high pressures needed to open the injectors. In the 7.3 and 6.0 liter Power Stroke engines, the high-pressure oil system mechanically opens the injectors. A failed injection control pressure sensor can send false values to the computer. The computer thinks pressure is low, refuses to fire the injectors, and the engine cranks forever. Replacing this sensor, which costs under $100, often fixes everything. Also check glow plugs in cold weather and make sure there is no air in the fuel system after filter service. Air in diesel fuel systems causes hard starting and extended cranking. But here is where this story gets really interesting for all vehicle owners. Number 11, stuck safety switches that prevent starting on purpose. Imagine this. You get in your car, everything looks normal. Dash lights come on, radio works, headlights are bright, you turn the key and absolutely nothing happens. No click, no crank, complete silence. Most people immediately think battery or starter. But here is what almost nobody considers. A switch smaller than your finger designed to protect you might be blocking everything. What is really happening? Safety switches like the neutral safety switch, clutch pedal switch, and brake pedal switch all have to complete their circuit before the car's computer will let the starter engage. When any of these switches fails, you get no crank at all. It looks exactly like a dead battery or dead starter. Early 2000s Hondas show this exact pattern all the time. Battery voltage reaches the starter solenoid input, but nothing happens when you try to start. The problem is a bad clutch switch or neutral safety switch that stops the starter relay from grounding. Here's the frustrating part. Many safety switches fail gradually. They work sometimes and fail other times with no obvious pattern. Owners go through frustrating cycles of uncertainty before someone finally finds the bad switch. In push-button start vehicles, the brake pedal switch does double duty. It disables cruise control and tells the car it is okay to start. When this switch fails, you get no start conditions that confuse owners. They do not expect a brake issue to stop the car from starting. But here is where most people make a big mistake. They assume no click means safety switch, but sometimes the starter itself fails so quietly that it looks exactly the same. Number 10, worn starter motor failure. What is really happening? The starter motor has brushes inside that transfer power to the spinning armature. Over time, these brushes wear out. The solenoid contacts pit and corrode. The bearings seize. Classic starter failure symptoms include a single click without engine turnover, repeated rapid clicking, intermittent engagement that works sometimes but not others, grinding noises from damaged pinion or flywheel teeth, and slow cranking that sounds sluggish and weak. Here is a classic mechanic trick. If the starter just clicks once and does nothing, try tapping it with a hammer while someone turns the key. If it suddenly works, the starter has internal wear. Maybe stuck Bendix gears or worn brushes. It is on its way to complete failure. Always check the battery and cables before you replace the starter. A starter that looks dead might be perfectly fine. The real problem is often not enough voltage reaching it because of corroded cables or bad grounds. A starter that tests perfectly on the bench but fails on and off in the car often points to heat damage or wiring that rubs against hot exhaust components. Honda Accord V6 models have a specific problem with starter pinion and flywheel tooth damage from misalignment. You hear grinding noises and the starter fails repeatedly. The fix needs updated starters and properly positioning the flywheel. Now here is where things get even more interesting, and this is something mechanics only learn after years of experience. Number 9, weak alternators that silently drain your battery. Have you ever woken up to a dead battery even though your car worked fine the night before? Most people blame the battery. They buy a new one. Then it happens again a few weeks later. The relationship between alternator health and battery health goes in circles. Alternator problems cause battery problems that then look like the main issue. Here's the key test. Check alternator output while the engine runs. Voltage should be between 13.5 and 14.5 volts. Also check for AC ripple, which means failing diodes. An alternator with partial diode failure may still charge a little, but cannot fully restore a weak battery. But what if your alternator tests perfectly fine and your battery still drains? That points to something else entirely. Number 8, parasitic drain. This is an overlooked cause of repeated no-start problems. Vehicles go flat after sitting for days or weeks. Owners keep blaming the battery when something else is draining it. What is really happening? Modern vehicles draw small standby currents to keep module memory alive, but a bad module, stuck relay, or aftermarket accessory can drain the battery over time. A proper parasitic draw test needs an ammeter in series with the negative battery cable. Then pull fuses one by one to find which circuit is draining the battery. Complex parasitic draw cases that resist simple fuse pulling often need professional electrical diagnosis. Common culprits include aftermarket remote start systems, aftermarket alarms, audio amplifiers, and lighting mods. But factory wiring faults, bad grounds, and door switches that think the door is open when it is closed can drain batteries just as fast. A simple fix while you troubleshoot is using a battery maintainer if the car sits a lot, or just disconnecting the negative terminal for storage. But none of this matters if fuel cannot reach your engine. And this brings us to a failure that sounds simple but hides in surprisingly tricky ways. Number 7, dead fuel pump. When fuel delivery fails, the engine has nothing to burn. It will crank forever without catching. The result? Flooded spark plugs, a drained battery from repeated cranking, and a tow truck bill. What is really happening? The fuel pump pushes fuel from the tank to the engine under pressure. When it fails, the engine has spark and air but no fuel. Without all three, it cannot start. Here's the quick test I mentioned earlier. The starting fluid spray test is the fastest way to tell. If the engine fires briefly on starter fluid, the problem is definitely fuel delivery. When you turn the key to on, you should hear the fuel pump hum for a few seconds as it builds pressure. No sound. Check fuses and relays first. Check for voltage at the pump connector. Do not blame the fuel pump until you have proven it is actually getting power. A classic BMW case shows how simple mistakes look like major failures. A 325 I cranked with no codes and ran on starting fluid but had no fuel pressure. The pump hummed, injectors clicked, everything seemed to work. The breakthrough? The fuel filter hoses got installed backwards during previous maintenance. This blocked fuel completely. Flipping the hoses fixed everything. The lesson? Just because you hear the pump running does not mean fuel is reaching the engine. Always check pressure with a gauge. But here is where things get really complicated. Number 6. Failed crankshaft and camshaft position sensors. A sensor no bigger than your thumb decides whether your engine runs or not. Your engine is basically a computer on wheels. And just like your laptop, if the processor gets bad information, nothing works right. What is really happening? The crankshaft position sensor sits near the flywheel or a toothed wheel on the crankshaft. It makes electrical pulses every time a tooth passes its magnetic tip. The ECU uses these pulses to know exactly where every piston is and how fast the engine spins. Without a valid crank signal, the ECU has no idea when to fire the coils or injectors. The engine spins freely, but never catches because the computer has no timing reference. When this sensor gets contaminated with metal shavings, burnt oil, or grime, the signal gets distorted. The engine may stall when hot, crank extra long before starting, or lose spark randomly while driving. Here is what shops discover all the time. Engines that look like they have serious ignition or fuel pump problems come back to life after nothing more than cleaning the sensor tip and connector. Metal shavings stick to the magnetic tip and mess up the signal. A clean cloth fixes it. The camshaft position sensor works with the crankshaft sensor, like two synchronized clocks. The crank sensor tells engine speed and position. The cam sensor tells which part of the cycle the engine is in. When either fails from oil contamination, sludge, or internal cracking, the ECU loses its reference and goes into limp mode. And if your engine has variable valve timing, the computer constantly checks that the cam and crank sensors agree with each other. If the timing chain has stretched or something is off, the signals stop matching and the computer shuts everything down before the engine destroys itself. But here is the part that scares most car owners. Number 5. Dead ECU and PCM modules. Even if your sensors work perfectly, the computer that reads them can fail in ways almost impossible to spot without special equipment. The engine control unit controls everything: fuel injection, ignition timing, sensor processing, starter relay activation. If it fails, nothing works. When the ECU cannot power up or talk to scan tools, no fuel injection happens, no ignition timing happens, and no sensor processing happens. The starter motor turns the engine, but nothing else works. Before you condemn an ECU, check power and ground at the connector pins. What looks like ECU failure might just be corroded power pins or broken ground wires. A vehicle with 12 volts at the battery can have 0 volts at the ECU if something is wrong in between. One case I saw had an aftermarket ECU that threw random errors and kept losing fuel pump priming even though it had 12 volts at the power pins. Bench testing proved the ECU worked fine. The real problem was intermittent ground faults and corroded connectors. Another documented case involved a Haltech Elite 2000 ECU that got damaged when someone welded nearby without disconnecting the battery and ECU. Welding-induced voltage spikes fried the internal circuits, even though fuses looked fine and 12 volts showed at the pins. The lesson: always disconnect the battery and ECU before welding on a vehicle. A Syvex S7 Plus case had the ECU repeatedly blowing its fuse when certain aftermarket peripherals got connected. Unplugging the peripherals stopped the fuse blowing and let techs figure out what was actually wrong. Engine swap projects bring their own ECU headaches. LS swaps into non-GM vehicles or Honda swaps into custom cars create no-start problems not covered by factory wiring diagrams. You need swap-specific documentation to figure those out. But here is what I want you to know. Number 4. Immobilizer systems that think you are a thief. Your vehicle has systems designed to stop thieves, and those same systems can accidentally lock you out. When the immobilizer decides you are not authorized, nothing works. The key turns. The engine cranks, but it never starts. You end up confused, calling a tow truck, and paying for dealer diagnostics when the fix might be a $20 connector cleaning. Your car has a whole chain of security components that all have to agree you are the real owner. A chip in your key talks to a sensor in the steering column, which talks to the dashboard, which talks to the engine computer. If any one of those connections breaks or gets corroded, the car thinks you are a thief and refuses to start. Generic OBD scanners usually cannot see Immobilizer faults. You need manufacturer-specific tools like VCDS for Volkswagen and Audi, ForScan for Ford, or Toyota TechStream to read the actual Immobilizer codes and starter-enable flags. In Hondas, a flashing key icon during failed starts usually means the Immobilizer is blocking you. In VW and Audi vehicles, the Immobilizer system connects the antenna ring, instrument cluster, and engine computer. Water getting in, corroded connectors, and aftermarket stereo installs often cause Immobilizer problems. One VW case shows this perfectly. A GTI would not recognize the key even though remote functions worked. The owner replaced the antenna ring. Still nothing. The actual problem was corroded instrument cluster connectors. Cleaning them fixed it. Another VW owner had constant Immobilizer warnings and a battery that kept dying. The crazy fix? Moving a storage tray under the dashboard. Wiring hidden behind it was getting pinched and causing random electrical faults. But here's another failure point that directly affects starting. Number 3, the ignition switch itself. This one has such dark history that it led to congressional investigations and criminal charges against major automakers. The ignition switch sits where mechanical key turning meets electrical power routing. Its contacts send power to starter circuits, ECU feeds, and safety modules. Mechanical wear from heavy keychains puts stress on the key. Years of repeated use wears down the internal contacts. The General Motors ignition switch crisis showed how a bad switch, combined with corporate failures, led to deadly consequences. The switch could slip from run to off unexpectedly, killing engine power and disabling airbags and power steering. People died. Massive recalls followed. Toyota had a similar ignition switch recall that hit over 6 million vehicles worldwide. The problem? Bad grease inside the switch let moisture and dirt get in. The contacts overheated and failed. A failing ignition switch can make the vehicle look completely dead even with the key on. Dash lights stay dark. The ECU is silent. Nobody thinks to check the $30 switch. But we are getting close to the most overlooked category of all. Number 2, body control module and CAN bus failures. Beyond simple mechanical problems, your car has a central computer called the body control module that talks to every other computer in the vehicle. When this communication network has problems, random systems start failing for no obvious reason. These are the failures that make car owners feel like they are going crazy. What is really happening? The BCM controls your locks, lights, security system, and a lot more. All the computers in your car talk to each other through a network. When one computer on that network goes bad, it can spread problems to everything else. One bad connection can make your whole car act possessed. Silverado and Sierra truck owners report complete electrical power loss, especially in cold or wet weather. You open the driver door and get no dome light. The dash stays dark. The truck does nothing until the fault clears on its own. This often points to bad BCM connections or water getting into module enclosures. Third brake light gaskets that fail let water into the cabin and onto electronic modules. You get expensive failures with symptoms that seem totally unrelated to water. How do techs find the bad computer? They unplug modules one at a time until the problem goes away. When they pull the right one, everything else suddenly starts working again. Fixing this for good usually means replacing the BCM and having the dealer program it to your car. The new module has to be coded to work with your keys and security system. But now we arrive at the final category. I saved this one for last because it connects everything we just talked about. Number 1, wiring and grounds. Remember the corroded battery cables from number 15? The bad grounds from number 10? The connector faults from number 5? They are all the same root cause: wiring. Every electrical part in your car needs power in, ground out, and a clean signal to the computer. When any of those paths fail, you get ghost codes pointing at sensors that work perfectly fine. Experienced techs check wiring first because they have learned the hard way. The part is rarely bad. The wire carrying the signal is. That corroded ground wire I mentioned at the beginning, the one that cost $800 in wasted parts before someone found it, that is not unusual. I see it all the time. Loose fuse box cables, corroded ground bolts, wires rubbing inside the loom, simple problems that look like major failures. So here is the bottom line. Before you spend money on parts, check your connections, wiggle your harnesses, clean your grounds. The answer is usually sitting right there, invisible, waiting to be found. Now you know what the pros know. Next time your car will not start, you will know exactly where to look first. But getting your car to start is only half the battle, because once the engine is running, there is another silent killer hiding inside your engine. It causes more problems than almost anything else. And just like bad wiring, 99% of drivers find out way too late. If you want to know what it is before it destroys your engine, watch this video next.